Greetings, comrades. My name is Steve McAllister. I'm a doctoral candidate in the Institute of Ecology and Evolution at the University of Oregon, and a member of the John S. Reed Club of the Communist Party USA in Eugene, Oregon. I'm here today in this video hoping to start a conversation within the party and without about the intersection of what I see as being two key threats to the safety and prosperity of humanity in the coming century. Those threats are global climate change and peak oil. Two things that you might have heard a little bit about in the media, but I don't think together. And it's the intersection of the two that I find to be particularly worrisome, especially from the standpoint of leftist activism and the priorities of the Communist Party. Before I jump into the conversation about these two threats specifically, I wanted to give some thanks very quickly to some of the people who helped make this video possible. Starting with the members of my club, the John S. Reed Club here in Eugene, who provided a huge amount of support and logistics to help put this video together. And to Juan Lopez and Tim and Joyce Wheeler, comrades who visited our club shortly after our founding back in January and saw a preliminary version of this talk and provided a great deal of valuable feedback and support in making this video and trying to get this conversation started at a larger level. So with that, I'd like to go ahead and jump in. Let's get this conversation started. So first, let's introduce the two topics that I'd like to talk about, climate change. And I'd like to state for this topic and also for the other one that I'm talking about that there's an awful lot of controversy surrounding topics that are scientifically incontrovertible. To start with, climate change. There can be no doubt that human action, chiefly through the burning of fossil fuels, although also through some land use change, is having a tremendous impact on the planet's climate. This has been called global warming in the past. It's more typically called global climate change now to avoid the oversimplification that frequently accompanies calling it global warming because what we're really dealing with is increased climatic instability as opposed to an even increased temperature across the world. I'll talk about that in a little more detail later. And I also want to talk about peak oil. And this is a term that more people are unfamiliar with than climate change. It's not getting as much time in the media. But peak oil refers to the inevitable depletion of fossil fuels. Humans are extracting a finite resource from the crust of the planet, and being a finite resource, we will eventually run out of it. And peak oil refers to a moment in history, the greatest debate being when this moment will occur, that we have extracted as much oil at a time as we can from the Earth's crust, and production will plateau and drop after that point. So these are two very simple concepts: anthropocentric climate change, the changing of the climate by human activity, and peak oil, the idea that we will eventually run out of extractable fossil fuels. These aren't really in debate, but there's an awful lot of controversy about the ramifications of these events. So to give you a quick map of where I want to take you in this conversation, we'll talk first about climate change. I'll introduce the mechanisms of climate change, as well understood as they are. And I will describe what we've observed in terms of climate change so far, the historical observations we have that provide proof that it's occurring. And finally, some predictions about where climate change will go in the future, what we can expect the consequences in the coming century to be of various different possible behaviors that we as a civilization can undertake. Then I'd like to go on to peak oil. Talk in a little more detail about what exactly peak oil is, the information that we have about when that peak will be reached, and finally what the consequences of peak oil will be under the current socioeconomic system that we have, the current world economy. And then to finish, I would like to talk about the consequences of both of these serious situations that humanity is facing in the coming century and of the intersection between the two of them. So let's get started. First, climate change mechanisms. Simply put, global warming is caused by radiative forcing, which is simply the degree to which greenhouse gases emitted by humanity trap radiation within the Earth's atmosphere. Anthropocentric climate change, then, is the warming due to the amount of greenhouse gases that are emitted specifically by human activities. There are a number of greenhouse gases that are emitted by natural processes, whether it's volcanic eruptions or the respiration of animals. So when we're talking about anthropocentric climate change, we're talking specifically about the greenhouse gases that are being emitted by human industrial activity. So let's be clear on that. So on the next slide, you'll see a very famous figure from the International Panel on Climate Change report from 2007. And before I go any further, I'd like to thank the International Panel on Climate Change, the UN's group of scientists that were commissioned to produce a report on the extent of climate change and the consequences of climate change back in 2000. It took them 7 years to do it. They published it in 2007, and it remains the definitive scientific summary of climate change science. And it was commissioned by the UN. It's published and freely available online. And I'll be showing a lot of figures and data from that report through the course of this video. And I'll show a link to where you can find that information online later if you'd like to check these data for yourself. So this figure is a historical chart of the concentrations of the 3 most primary greenhouse gases in the Earth's atmosphere over the course of the last 10,000 years. These are in descending order of importance: carbon dioxide, methane, and nitrous oxide. We'll be talking mostly about carbon dioxide and methane being mineralized carbon that are most frequently emitted by the burning of fossil fuels. So you can see on all 3 of these charts, the so-called hockey stick diagram, that the concentrations of all 3 of these atmospheric gases held more or less constant for the vast majority of the past 10,000 years, until you reach approximately 150 years ago, right around the beginning of the Industrial Revolution, when the concentrations of all 3 gases spike precipitously. This is as a result of the burning of fossil fuels in the industrial age. With atmospheric concentrations of all 3 of these gases increasing drastically over the industrial age, these account for the majority of the anthropocentric radiative forcing that is driving global climate change right now. And this amounts to approximately 1.6 watts per square meter. Now, before I jump in any farther, I want to explain that number. That's an awfully abstract number, 1.6 watts per square meter. What does that mean? Well, that is simply a measure of the amount of energy that is striking the Earth continuously, warming the Earth continuously as a result of the presence of these gases in the atmosphere. 1.6 watts per square meter, which is roughly equivalent to having a 100-watt light bulb suspended above a 30-foot by 30-foot room. Now, that's a single light bulb in a pretty large room, so that doesn't seem like a whole lot of energy. You're not going to be catching a tan under that or anything. But imagine if the Earth is completely covered with those rooms, with those 100-watt light bulbs, and they never, ever turn off. When you think about the size of the Earth and how long those light bulbs are on, you realize that over time, this is a significant accumulation of heat energy on the Earth, and that is what's driving global climate change. What are we actually seeing in terms of climate change beyond just this accumulation of energy because of this buildup of greenhouse gases? Well, there is a tremendous body of literature detailing with great confidence, and I want to stress that, there is great confidence that the changes the global climate has already undergone. And with the exception of error boundaries, as noted on the figures that I'm about to show you, and I'll explain those in a little bit, I want to stress that these findings are not seriously in doubt. The historically observed climate change is a settled issue. Climate scientists agree very much on the measurements of increased temperature, increased sea level, decreased snow cover, all of these historical measures over the course of the last 100 years or so. The only debate that exists, and there's precious little of that, is over the projections in the future, which I'll get to in a few minutes. So on this next figure, we see historical measurements of global mean temperature, global mean sea level, and snow cover. And this is where I want to explain what I meant by error bars on the last slide. Those blue shaded regions represent an area of uncertainty in our measurements. We are 95% confident that the temperature for any given year falls within that blue shaded region. The black line passing through that blue shaded region represents the mean, or our best possible measurement. So that blue shaded area represents a certain cloud of uncertainty around our estimate of the temperature. So this is important because we can quantify our uncertainty based on the data that we have and know roughly how good our estimate is. And you can see from this top figure, which is global mean temperature over the course of the industrial era, that this is still showing a very distinctive upward trend, despite any uncertainty in the measurements that we might have. And this is important because a lot of critics of global climate science will try to claim that there is uncertainty in the measurements, and this means we can't draw any conclusions from the data at all. And that is simply not true. We can quantify the amount of uncertainty we have in our data and still make significant projections based on that data. So what you can see here is that temperature has been increasing substantially over the course of the last century or two, as has the mean level of the sea. This is a result of melting of glaciers and retreat of ice caps, which has vastly increased the amount of water entering the ocean versus the amount leaving it through evaporation, which has been slowly but steadily driving up the level of the sea over the course